And good morning or good afternoon, wherever you find yourself today. Welcome to our webinar. My name is Mitch Mershon. I'm a senior product marketing manager here at Keyfactor. And I've got the distinct pleasure of having Byron McNaught and Mark Thwaites with us. And today we're going to be talking about PQC, but also how it ties in with F5. F5 is a great partner of ours here at Keyfactor. We've been doing some great things. They're all over the world. And we've really found a great niche between us that you're going to be able to see today of taking all that they do and being able to simplify the certificate lifecycle management that goes along with that. I could sit here and talk ad nauseum about it, but I think it'd be better if I just let the experts talk. So I'm going to hand it over to Byron. He's going to walk us through some PQC, and then Mark has got a great demo to show you how it's done. One little housekeeping item over on the right-hand side of your screen, if you do see a little paper clip, that's the attachments. We've got the ability for you to directly log in and book a meeting with one of our PKI specialists. You've also got some other resources. You can connect with us on LinkedIn, see our data sheets. And one last big thing over on that right-hand side again as well is there's a question mark. If you have a question about anything as it comes through here, we will get that answered for you. And if you are watching this on demand, go ahead and also type in any questions. We will see that and be able to get back with you. So with that, I'm going to hand it over to the experts. And Byron, go ahead.
Thanks. I'm really happy to be here with Keyfactor. We've done some work in the past. If you attend some of the cybersecurity conferences, RSA and soon to be Black Hat, and yeah, it's absolutely a team effort here. This is a pervasive situation that we're going to dive into, and while no single vendor can handle it all, definitely with F5's longstanding role in doing SSL TLS offload and encryption, decryption inspection, along with Keyfactor's expertise in automation, it's really going to help you with your tools when you get a handle on this. So let's dive in. And this isn't intended to be a masterclass. I don't expect you guys to be experts in cryptography. I myself am not, perhaps, as compared to some of our technical fellows here on F5 or on the engineering side of the house, but I have dabbled in it for a while. I used to be on the product team, and we have a product called SSL Orchestrator that's purpose-built specifically for some of this cryptography. So we're just going to kind of do a little primer, kind of level set, because there's a lot of acronyms, and perhaps not all the audience knows what they all are, or perhaps you are in certain parts of your IT group, but we're just going to level set here. So what is quantum computing? So this is a type of computing different from classical computing, which is kind of what we're all used to, ones and zeros, computer science, on, off, switches in terms of the logic and the software that basically runs everything. So quantum is different. This is an advanced type of computing, and there's no longer this binary 0 or 1. Qubits, which are used underlying the way that the computing is done, can actually be a superposition. They can be in multiple states at the same time. So again, we're not going to get into physics. Myself, I took physics in college, and it was kind of like, well, that was one of my toughest classes. So we're not here to make you experts in quantum, but just know the meta point is this is a completely different paradigm, a completely different kind of computer. And effectively what it allows is to process so much more information and to be able to solve problems much faster. And this is really going to be important as we dive into what does this mean for cryptography. So again, we're not here to make you experts in the math, but definitely want to do a primer here. I pulled this from some of our internal enablement, actually. So for those that don't know, RSA, which is, I don't want to say the de facto standard, but it was at one time the most popular way that public key cryptography was implemented. And if you're using Keyfactor, if you're using F5 systems in the wild, so to speak, you probably know what RSA means, but it actually goes back to 1977, and it relies on intractable factors of semi-prime numbers. I know that's a mouthful, but basically what the math is trying to do is make it such that you're trying to exchange this private key that's really critical for being able to create these ciphers to hide the messages. That's effectively what encryption is. So how do you exchange this information over an insecure channel, the internet? Well, it uses this math, and in particular, it uses really large prime numbers that are really hard to factor because they're semi-prime. And so it basically makes it really difficult to get that key information so that you can decrypt the information. So keep that in mind as we continue to track through this. Well, something happened, somewhat of a scramble in the industry So ECC was introduced in 1985, but it was much later than that that we started to implement it. So this kind of takes the math to the next level. It's really complicated, so we're not even going to be able to get into all of it, but it effectively uses algebraic structures of elliptical curves over a finite field. You're like, what the heck does that mean? So there's a lot of parameters here, but it's basically coming up with a curve so that reverse engineering it with a classical computer, just like with RSA, requires tons of compute. We're talking about perhaps millions of years, right? So keep that in mind before we jump into quantum. But something that I find particularly interesting, so when the industry knew we had to pivot to stronger cryptography, and we're going to dive into this a little bit later, it's not always that the math is vulnerable. In many cases, it's the implementation. There can be vulnerabilities. There can be software weaknesses. There can be defects. I remember Heartbleed. That was a major situation on the internet. But as an industry, and F5 in particular, we sort of drove to this moment of we need to move to ECC. It's more hardened, it's more resilient, and in many cases, it's even faster. It can be hardware optimized. But something that's really interesting was when the NSA, we're talking about the U.S. government, who's actually a foremost expert on encryption, decryption. They announced in 2015, I believe it was at Black Hat, that perhaps we should hold off on ECC. We need to move to post-quantum. So think about that. So this quantum phenomenon, so to speak, it's not new. Some of the major players in this space have known about it for some time. So just to level set, RSA, ECC, they're not new. They're very widespread. They're very secure, if nothing else, because they've been proven. And yes, there's been vulnerabilities and they've been resolved. And yes, the math is such that it's really difficult to reverse engineer, so to speak, until quantum. But before we get to quantum, there was another development. We called it perfect forward secrecy. This is pretty much where we are now in terms of the highest level of security in classical cryptography. So remember earlier we talked about the complex math to be able to get that private key that's actually used to do the ciphers and the signing to basically make sure the messages are secure, to make sure they're not modified, that integrity aspect. Well, we're going to send a session key per session. Every time we do that connection between a client server, there's going to be a session key that's unique to that session between those two bodies that are communicating. And since it takes millennia to crack these, again, with classical computers, it's perfect. So look at that graphic there, because we're going to dive in later to what that means. So we're going to do a primer now on quantum, because we talked about the classical computing and what that means for classical cryptography, but now we're entering a new world. So before we get into the PQC, or the post-quantum cryptography, let's just talk about quantum and level set in general. So this has the potential to revolutionize fields limited by classical computing, again, because of the multiple states that the qubits can have, and just the sheer amount of information and problem solving and number crunching that they can do. This is going to unleash all kinds of good things. Think about drug discovery, in particular artificial intelligence, and we're really seeing this nexus in terms of, I don't want to say a hype cycle, but there is a lot of movement on both the AI front and the post-quantum front at the same time. But this is going to revolutionize all kinds of fields, and definitely in ours here with security. So here's the threats, and we're going to kind of dive into what does this mean. So basically, because of the power of quantum cryptography and the number crunching that they can do, these classical algorithms like RSA and ECC, they will be broken. It's not a matter of if, it's a matter of when. And the backbone of internet security is at risk. NIST, again, one of those standard bodies that we look to, they're basically projecting that it's coming within the decade. And when that happens, it's called Q-Day. And what that means is we already know that there's nation states, bad actors that are harvesting all kinds of encrypted messages now, so that when they are able to have a quantum computer, which, by the way, the hyperscalers and some of the other big dogs in the technology space are providing as a service, that they will be able to break those messages and they will be able to see them in clear text. So, like me, you probably thought if you're using strong encryption, you're using Apple iMessages, or you're using, if you've implemented it in your enterprise, you're using ECC with all the highest levels of security. None of that's going to matter when Q-Day happens. And some of the research that's coming from our threat team, F5 Labs, they're not projecting that Q-Day is going to happen this year, but in their predictions report, which they do every year, they're suggesting that AI is really going to sort of accelerate this challenge to where we're going to get to the state of insecurity on the internet. And what I found so interesting is because AI is going to unlock this ability to do what's called side channel attacks. Basically, the attackers can monitor physical signals, power consumption, electromagnetic emissions, processing times, and then can infer information from that to reconstruct the private key. So remember, the encryption is all about hiding that private key because that's used to do the encrypt, decrypt, the signing to make sure that the message is not only not able to be revealed, but also not modified in flight. So AI is going to, again, provide this computing power to basically reconstruct the private key. So that's really significant. Again, just like with RSA and ECC, they're not insecure by virtue of the algorithms or the mathematics behind it. It's more of the implementation. So the same thing with AI. And another anecdote I wanted to share with you is from our field CISO. He kind of travels the world. He comes back and he creates a master deck that we all steal from because it's great stuff. We're not good at prediction curves. So remember the NSA projected like, hey, maybe we should just not worry so much about this ECC thing and just move to PQC. There were some projections that post-quantum Q-Day, this ability to use quantum computers to break the classical algorithm is going to happen in 2025. That so far has not happened, but 2025 is when we're seeing these advancements in AI to perhaps break some of the implementation of classical crypto. But we're not good at prediction curves. What do I mean by that? So the first public available API from Salesforce was introduced in 2000. Fast forward to 2019, almost 20 years, we had the OWASP API security project, which is great. But that's 19 years of us trying to figure out what to do as practitioners, right? Generative AI, when are we going to reach this AGI moment or general artificial intelligence where AI is basically better than humans at almost everything? There were projections that it's 2040 to 2070. Satya, CEO of Microsoft, remember that handheld I showed earlier? He said, we believe this breakthrough will allow us to create a true meaningful quantum computer, not in decades, but in years. And so the banks, the telecommunications providers, our customers, they're already asking us now. We have a really solid roadmap, which we're not going to get into all the details of that. But every organization, every industry needs to plan for PQC. That's the reality. And because it's going to threaten critical infrastructure, think power grids, in particular financial networks, anywhere where there's sensitive data. Think of all the highly regulated industries that both F5 and Keyfactor are very familiar with, those regulations and those stringent requirements. Telecommunication networks, because you can think about sensitive information, think about phone calls. Leaders of countries across the world, they do talk to each other. They do want to have secure communications. Everything is at risk right now. And not only are our nations trying to develop quantum computers, but the hyperscalers, like I talked about, they're already as a service platforms to help you get there. So some of the other research that's coming out from F5 Labs, they basically partner with some organizations, get into sensors and whatnot, and basically do a lay of the land, like what's the posture across the whole internet. The good news is that 84% of the top 1 million sites, we're talking about websites, classical web apps, prefer TLS 1.3, which gives them the potential to support post-quantum cryptography. That's a good thing because basically TLS 1.2 and earlier do not support it. So if you're not on TLS 1.3, that's step number one. 100% of the top 10 sites support TLS 1.3. That's great. The flip side is that starts to drop dramatically as you start going down to some of the sites that are not at the top. And one of the challenges is the browser support. So Google Chrome is a leader here. They actually have 56% of the connections that we observed in this research. They were using Chrome, and they are actually PQC ready. 93% of Chrome users are already using a PQC ready version. Flip side is Safari doesn't support PQC. So again, this is an industry-wide problem. Even as vendors, F5 can help you secure your communications. Keyfactor can help you automate the inventory, the management, and the implementation of that. And we're going to show a really great demo in a minute on how to do that specifically. But you got to think about browsers or other protocols that are not, web-based. This is such a pervasive issue. And something that was really interesting, probably not surprising, the supermassive sites, think the Googles, the Facebooks, or whatever they're called now, Meta, sorry, of the world are leading the charge. In fact, there was a really good write-up from Meta on their internal implementation, and it's getting into the weeds, but you can see the challenges. The way PQC works, it requires more space. This is challenging, MTU and retransmissions. Think engineering at scale. This is a massive problem. But sites that are actually using CDNs perhaps are in a better position, because actually Cloudflare, hate to say it, they're one of our competitors, but give credit where credit's due. They're pushing really hard on being able to deploy quantum resistant ciphers in their network. So that's just based on our research, scanning the internet, and we are going to break it down by industry. Every industry is still pretty far away from being in a good space. And again, we're not going to make you experts here, but just to kind of break it down, what does all this mean? This is modern cryptography. In this case, we're talking about TLS. And I believe this is 1.3 right here. You can see the key exchanges using ECC. It's actually taking a hybrid approach, but the main things you have to remember is we have the authentication, which is basically that key exchange. We have the encapsulation, and then we have the signing. So think about, CIA triad, confidentiality, integrity. There's multifaceted here, and this is where the PQC comes in, because it's not going to be a completely let's get rid of all this and start new, because we know that what's first going to happen with this QDARE, where quantum computing becomes a reality, is the CHEM and the HMAC, basically the digital signing algorithms, will be the first to go, basically going to be useless. And here's some of the new stuff, and this is so much jargon here, so bear with me. We're not going to dive too much into this, but NIST, they've already introduced 3 or 4 standards that I believe are ready to go. FIPS 203, 204, 205. There's some drafts coming. Basically, this is to change some of those components and make them more resistant to quantum computing. So, but the overall meta point is we're taking a hybrid approach, because we don't actually know what's going to happen. There could be PQC algorithms that turn out to be insecure. So what the hybrid means is we're basically going to take the output of 2 cryptographic algorithms to create the session key. So we're going to use perhaps ECC, Diffie-Hellman, which is a classic type of cryptography, with the PQC KEM to add a layer of encapsulation to make it even more secure. So F5 already has support for some of this, and we have a pretty robust roadmap, and we are monitoring the situation to make sure. But just keep in mind that you're not going to have to throw away everything you've already done. This is going to be an evolving and basically an iterative process, but there is going to be a forcing function. So what if you do nothing? That's always a problem in sales. We're not here to sell you anything, but the do nothing approach isn't going to fly, because cryptography is going to be broken. It's not a matter of if, it's a matter of when. The harvest now, decrypt later, that's absolutely happening. The clock is ticking. And some other anecdotes from our field CISO, he says this is the first time in 25 years that he's seen that we're really trying to get ahead of it. Again, I riffed on his work. We were late to the game on API security. We're late to the game on securing generative AI. PQC, NIST, NSA, other standard bodies out there, other players, they've known about this for a while. We are in actually a pretty good position on the guidance. The implementation is going to be a lot harder. Thank God we have companies like Keyfactor to help. And some of our customers, I'm not going to name drop, but some of the top US banks, they have 30 million endpoints to update. Just let that sink in, the magnitude of the problem. Because we're not just talking about your web servers. We're talking about devices, all of your infrastructure. It's not just web protocols. It's any type of a protocol that's leveraging encryption. And there's 4 major technology drivers right now. We have APIs and API security. We have AI, generative AI, the security thereof. We have geopolitical issues, which we're not going to get into, but I'm sure if you're watching the news, you know what I'm talking about. And then we have PQC. So this is a major technological phenomenon, if you will. It's one of the top ones. A more prudent approach is to take a PQC readiness strategy. So you need to do your inventory. You need to do your scenario planning. You need to watch what's happening with NIST. You need to watch for the new standards. Are they being ratified? Are there algorithms that are going to be deemed, not good enough? Are we going to have to switch some things out? We need to get a handle on that. You have to do the integration across the board into your development cycle, across your infrastructure. And this is really where the automations have become key. And then there needs to be an awareness because users play a role here. Are they using a PQC ready browser? Have they updated, Chrome to that level that we need to have that robust protection? And in particular, where F5 can help, we've already introduced PQC resistant ciphers in our big IP product family, in particular version 17.5. It does support the hybrid key encapsulation because, again, we're making sure that we take a prudent approach. And then Nginx also supports it. There is some customization required because under the hood, there is some OpenSSL and some cryptography libraries. But in a sense, Big IP and Nginx support it. And there is a roadmap basically as we move along. And like I said, the magnitude of the problem is so vast. So it's going to require automation. Unfortunately, we have Keyfactor with that. And I'm going to turn it over to my Keyfactor partners now and show you specifically how they can help you with this readiness approach.
Hello, everyone. My name is Mark Thwaites. I'm a solution engineer at Keyfactor, and I work with all our great technical partners, specifically F5, who we're going to be showcasing today in our demonstration, where Keyfactor Command is going to be integrated with 3 different integrations that we have with F5, which is going to be Big IP, Big IQ, and their distributed cloud. Now, Keyfactor Command is our certificate lifecycle management and automation platform. So this is where we can go ahead and discover and manage that crypto directly within F5. And then Command is also going to be connected directly to your PKI of choice, whether it's private, public, or maybe a combination of both. Now, why are we doing this? The main reason is that we want to increase productivity by doing automation, just the manual operations of doing this. Specifically, if you have hundreds and thousands of endpoints that you're managing, can be very cumbersome. We want to be able to maximize uptime of those different services within Big IP. And then we also want to be able to secure the certificate workflows, right? And these are all going to be things that we're going to see throughout all our 3 integrations that we have specifically with F5. All right, so just to kind of talk about some of the different components we have here for an integration, and we'll see that this will overlap into the other integrations we discussed today. We're going to have Keyfactor Command. Now, Keyfactor Command is a certificate lifecycle management automation solution. This could be hosted on-prem. This could be, in the cloud, where Keyfactor could even host this as well, or even provide PKI as a service, which we'll talk about here in a minute. You can see your administrators are going to be able to log in and they could go ahead and set up the integrations, but the integration itself is really going to be tied to the orchestrator framework. The orchestrator is a lightweight utility that is deployed within your data center. Again, could be on cloud, could be on-prem, and then this is going to be able to communicate not only to F5, but also to Command, because Command is going to queue up jobs, it's going to go ahead and perform to be able to do things like inventory and discovery, and also the delivery and management of the actual certificates themselves. Now, the certificates themselves, those are going to be minted against your integrated PKI, whether it's private or public. And what I'll be showcasing today is specifically using EJBCA Enterprise, which is Keyfactor's private PKI. And this becomes extremely important because EJBCA Enterprise does support Post-Quantum Cryptography. So as you're starting to look at how you want to, let's say, flip that crypto on your endpoints, specifically in this case F5, Keyfactor Command is going to be able to allow you to do that. Now, we'll talk a little bit about what I'm doing today and what the future looks like, but this is definitely, these 2 products coming together allows you to have that solution in play. All right. Now, going back to the orchestrator itself, how does it do the integration with F5? Well, you need some type of repository or binaries that would be loaded into the orchestrator, specifically built for the integration. And that's something you would grab from our GitHub repo. And we'll talk about that here in a second. And then down here, these are the different options that we have available for integration with Big IP. So we can manage certificates tied to SSL profiles. It could be tied to your CA bundles, and also the actual web server certificate that is bound to the actual F5 appliance itself. And when we look at this, there are kind of 2 different operations, really inventory and discover. We want to be able to identify what's there so we can go ahead and put it under management. And then our management operations are things where we can add, remove, and replace that crypto. And this is where PQC comes in, right? We want to be able to maybe take older crypto and replace it with newer crypto. And our platform is going to allow you to be able to do that. All right, now how do we get the actual orchestrator extension into the orchestrator so you can get registered with Command? pretty straightforward. What you would do is you would go into our GitHub, you would download the zip file. This is the latest and greatest as of the time of this recording. So always make sure you are grabbing the latest. You'd extract it and load it directly into your orchestrator into the extensions folder. And then when this actually, the orchestrator gets restarted, it'll go ahead and register that capability as long as you have a corresponding certificate store type defined. And we'll talk a little bit more about that in the demonstration, but that's something you can easily set up manually or maybe even using an API or doing in a bulk capacity. So in this diagram here, or this snapshot, you can see I have 3 different integrations listed here where I've downloaded each repo and extracted it directly into my orchestrator. So those are all registered directly within Command. Once we have it registered and it's approved, then we can start setting up our certificate stores. Certificate stores are really unique to Keyfactor Command, but this is really the endpoint or the service or maybe even the key store where the certificate or certificates reside, where they're being consumed by the platform itself that we're integrating with. So you'll have things where you would have like an IP or an FQDN, maybe a partition where the certificates live, which orchestrator is going to do the work. You'll have maybe some specific settings specifically for F5 in this case, and then how you're going to authenticate and how often are you doing, let's say, an inventory directly against that endpoint. And these stores, they could be created manually, they could be done with an API or in a bulk capacity, which we'll speak to as well. Okay, so I'm going to get directly into my command instance so I can show you some of these parts. I'm just going to log in with my Keyfactor IDP, but you may have another IDP that's connected to command using OAuth that you can definitely use. All right, now, first thing I'm going to do is I'm going to jump right over to my orchestrators. So I'm going to go to Orchestrator Management, and these are my orchestrators I have deployed where I have those extensions already loaded, right? So if I go into my Windows orchestrator, and it could have been a Linux distribution or even a container, I have these different capabilities loaded right here. So you can see I have like different F5 functionality listed, and that's based on those repos being loaded in my orchestrator and then registering directly with command. Now, I am using the latest and greatest orchestrator and the latest and greatest command instance, right? But you don't necessarily have to get the base functionality out of the F5 integration. As long as your command instance is on version 10.4.1, you can benefit from all this type of functionality that we're looking at today. You're just going to be able to get more functionality out of the command platform as you start upgrading the actual instance itself. Okay, so where do we get the repo from? Well, what we can do is we can open up another tab. I can go directly to github.com/keyfactor. Here, I've actually filtered it off F5. And then this right here is my repo specifically for Big IP. There's the binary I could download, which I mentioned earlier. And then we have details about the overview of the solution. Here we have how to set up the certificate store types that I mentioned earlier, which you would do before you restart your orchestrator to check in and register the actual capability that you just loaded, and then the actual setting up of the stores themselves. Okay. Now, in my case here, I've set up the stores manually, but you could do this with an API or a bulk capacity, which we'll talk about here shortly. All right, so let's go ahead and take a look at the actual cert stores. Okay, so I went to locations and cert stores. These are all my integrated cert stores. I have a lot of different types here. Keyfactor has a lot of different functionality and capabilities for managing certificates where they reside. So I'm just going to filter this based off a container definition I have defined. This is just one way to do the filtering. And these are all my integrations down here for F5. These first 3 here are specifically for Big IP. And if we go ahead and take a look at the integration here, we can see, what we had represented on the slide earlier, right? So you can see here I have the machine I'm connecting to with the port. This could be an FQDN, the partition where the certificate or certificates reside, which orchestrator is doing the work. This primary node online required is really kind of unique to F5, where maybe you have more than one node, and you can basically tell Keyfactor how to be able to manage that. Does the primary node to be online so that we can process these certificate operations, or can we do it when the secondary is online? So if you want more details about this, you can definitely take a look at the repo on what that configuration entails. Are we ignoring SSL? How are we authenticating? With a token? Or are we using maybe basic authentication with a username and password. Or maybe you're pulling in the credentials from a PAM provider. I just have a couple in my instance here, but we have a lot of different PAM providers or secret engines that we manage or integrate with, such as Hashi and CyberArk. So that could definitely be an option there. So you can define how you want to authenticate directly to F5 with different options for a secure connection. We're going to communicate through SSL. This down here is how we're managing or securing the actual private key material for those certificates that we're pushing into F5. And then how often are we pulling an inventory directly from that F5 integration. Here I can go ahead and right click and then I can view my inventory. So this shows me all the certificates that are in that partition that I have currently under under inventory. So that means I can manage them accordingly. So I could take a look at one of these certificates and actually I can query it and then review that certificate in more depth. But I really need to perform that type of operation directly within my certificates search window if I want to do something like a renewal manually directly within the platform. All right, so let's go ahead and take a look at that. So if we go to certificates and we go to certificate search, these are all my certificates that I currently have in inventory in my environment, right? And this is actually the certificate that we're going to go ahead and be looking at today for my demonstration. All right, so this will be the one tied to my big IP. I've got a bunch of them here because I've been doing a bunch of renewals over the past few days for this demonstration. And you can see it's tied to my big IP based off that certificate store type definition. And if we actually take a look at this certificate, these are the last 4 of the serial number. So we're going to match that to my big IP so we can see that that certificate is the one that is being managed. So when we do a renewal, we'll see that that asset will get rotated. So let's go ahead and do that. I'm going to go ahead and jump over to big IP. Okay, I'm going to go and log in here. All right, and all certificates are going to be under System, Certificate Management, Traffic, Certificate Management, and then SSL cert list. This is just doing a wildcard to show all the certs. But I have this tied to an alias of mark-demo-1. That alias becomes very important because that's what we're using to overwrite the certificate when we're doing a renewal. So it gets bound, or it continues to be bound to the different services it's tied to. And then this is the actual certificate in play, right? So there's the exact same serial number we saw earlier. That's the end entity cert, and then we also have our chain here as well, okay? And this happens to be tied to my EJBCA instance, which we'll talk about here in a minute. Now, let's go ahead and see what the certificate is actually tied to. So if I go to instances, you can see it's tied to this instance, which actually happens to be a SSL client profile. And this is the actual certificate that is defined, where we have the certificate key and chain, which is going to be pulled from that common location. And then if we go a little bit higher up within our hierarchy for, let's say, virtual servers, I actually have this being tied to a virtual server for that specific profile. So the big picture here is that if we need to renew that certificate before it expires, we want to make sure that we're not disrupting any of this type of process. So it's going to be tied specifically back to that same certificate in the common folder, if that's the partition that we're integrating with. And when it go ahead and gets renewed, it's going to be maintained and associated with these different configurations. So let's go ahead and do a renewal. I'm going to go ahead and click on Renew directly in Command. Here I could do a one-click renew, and it renews everything based off the existing information that was associated with its original minting. Or I can go ahead and do Configure. Configure allows me to change maybe the CA or the template that is tied to it, plus other configuration settings that are associated with how the certificate will get enrolled, and then maybe additional details on where it's going to actually be deployed. So in this case here, you can see I have different enrollment patterns, which are tied to maybe a different CA or template that would do the enrollment. I have a lot of different certificate authorities connected to my instance here. So I have like an instance of AWS as private CA. I have a Microsoft certificate authority. I could even tie it to maybe a public certificate authority where I have DigiCert connected, but we have a lot of different integrations there as well. I have 2 instances of EJBCA, and I'm actually going to pull it directly from this instance here, which is a Post-Quantum Cryptography lab instance that any of our customers could spin up and get some hands-on exposure, to those new algorithms that are available. Now, I'm not going to go ahead and enroll against a PQC certificate authority today because it's coming very soon, right? So I said I was on the latest and greatest. It's my understanding on the roadmap that the next release or the one after it is going to support the ability for us to be able to do enrollments for post-quantum certificates in that release, and then also have the orchestrator pick up that work to be delivered directly to the integrated endpoints. So in this case here, F5. This is also going to be starting to look at hybrid certificates as well. I'm not saying it's going to be in the next release, but that's something that we're also looking at as well too. All right, so RSA today, but very soon post-quantum that we're moving towards for enrollments and also orchestrator delivery. Now, we could do on-device keygen, which we'll talk a little bit about with Big IQ in a minute, but we're just talking about what we can do at this moment for Big IP. Okay, so you can see down at the bottom here, it'll install in current certificate stores, or I can maybe specify different stores I want to push this certificate. I'm going to go ahead and click on enroll. And then what's going to happen here is my command instance will go ahead and renew the certificate against that CA, against that template. And then there'll be a orchestrator job that'll get created to take that certificate and update it on my integrated F5 instance so that those services that are bound to that certificate would be able to pick up that new crypto. So if we go to certificates and search, we should see a new certificate associated for that specific, subject, right? All right. You're going to see down here that it's got no location tied to it yet because the orchestrator hasn't returned back that inventory from F5 until it, performs that type of operation. And then if we go over to orchestrator and jobs, we're going to see that we have that job listed here for an immediate operation. All right. So what's going to happen here is my deployed orchestrator needs to check in. And then when it checks in, it's going to see that this job is pending. And then it's going to go ahead and process it and then deliver it to that integrated certificate store that I have under management, right? So if we go ahead and refresh this, we should see that the job has been completed, right? And then we can go to our job history here, and we can see that the immediate job was completed successfully for that management operation. So we should see that on our Big IP device. And then you can see here the inventory is actually in process. So this actually should complete with success. So we can see that new inventory in our certificate search, right? So we can go to certificate search again. We'll be able to see that that is now tied, to that location. And if we wanted to, double check on this, we can actually bring up that four last digits of the serial number, so F3C7, and we'll confirm that directly within our F5 tenant here. All right, so we'll go back there, and then you can see that that is now under management. So not only are we discovering that inventory, we're also managing its life cycle. Now, right now, I just did it manually where I did it renew, but you could schedule this with an API to make it automated, or a little bit later on, I'll show you another demonstration where you can have this happen all based on configurations that are just going to trigger this when the certificate is coming up for expiration, which is a very powerful automation flow as well too. Now, if we go back to command, I do want to show you the other integrations we have available too. So if we go back to certificate stores and we go to a container, and we'll just filter these again. We can see that I have an integration here for CA profiles and also our web server certificate. That one's probably the easiest one to understand next, because what this is it's basically just the certificate that is tied directly to that F5 instance. So we're able to inventory, and we could also renew that certificate. So I could do that right now by doing a query and then renewing that certificate, or I could schedule it as a job with an API, for example. So that could be an operation as well, or automate it before it expires with, let's say, an expiration alert. This one here, these are my CA bundles, right? So I currently have this individual bundle under management, right? There actually happens to be more bundles over on the F5 side, and I'll show you those here in a second. The configuration is exactly the same as like my SSL profiles, but I'm managing a bundle here. So this happens to be my chain of trust, right? My root and my sub CA that's tied to that end entity cert that I just issued a minute ago for my alias of Mark Demo 1. Okay, so this is going to have the corresponding bundle in F5, right? So we can come over here and go to the bundle list. This is the one I have in question. Notice I have a few other ones here listed that don't have under management with command yet, but I'll speak to those in a second. but we can see that there's that included bundles there, right? And then if we wanted to actually see the actual certificates in play, we can actually do that under SSL certificate list, and we'll just change our search to EJBCA, and then that's the actual bundle we have in play. And then you can see those certificates there. So not only are we able to discover the bundles, which I'll show you here in a second, but we can also inventory the contents of the bundles and then manage the actual certificates in the bundle. Okay, and this is actually being used by something I have set up directly in F5. So if I go to instances, you can see I have it tied to 2 different configurations. And in this scenario, I actually have it tied to a trusted certificate authority. The use case here, and you can definitely check up on F5's documentation, but what you could do is you could say, hey, I'm going to associate this bundle with maybe this profile, and maybe I'm doing client auth or maybe using a smart card. Any certificate that's being presented would have to be associated with this bundle or this trust chain to be allowed for use, right? So that could be an option there, but we're managing the bundle in this case. And then if we go back to command, you'll notice that I have like this tab here that says discover, right? And if we actually go back to the GitHub repo, we have the ability where we can do discovery, right? So what discovery does is it says, hey, maybe I want to schedule the discovery of all my CA bundles based off a partition, or I want to do a scan of all my SSL profiles based on a partition. So I can define the orchestrator, I can define the client machine, credentials, and the directory to search, maybe a wildcard, and it can return all those back. So in this case here, I've got maybe a PQC bundle, right, that maybe I want to go ahead and put under management, or maybe even a hybrid bundle, right? So those could be some possibilities there. And then we also have like another partition I created for maybe some certificates that are in this test partition, right? So that could be an option there too. And I can click on manage and then start putting that under management, so it becomes an official search store that you're managing directly in command. So you're pulling that inventory and then you're managing the certificates directly within that search store as well. Now, when we start talking about this from, let's say, a bulk capacity, you can definitely do this with APIs, so not everything has to be done manually directly within command. Another thing I would probably say is I would look into our KF-util. Our KF-util is basically a lightweight utility that can connect to command using BASIC or OAuth to perform bulk operations using our APIs. So if you're looking to create hundreds and thousands of stores for all these different types of F5 instances that you have deployed across your entire enterprise, this is a way to be able to do that, right? So not only can we discover them, we can also set up these stores for the full management as well. And this could be done with maybe ingesting a CSV file that would be able to trigger APIs to be able to do all this type of configuration directly within command itself. Okay, so let's go ahead and take a look at the next integration here. The next integration is going to be for BigIQ. We're not going to go through this slide because it's exactly the same as what we saw before with BigIP, but there will be a different GitHub repo that you would download that extension for. How it's loaded and how it's registered with command would be the same. Just make sure you have the same, you follow the steps to be able to get the certificate store type registered before you do that. And then for functionality, we can do inventory, and then we can do management. So we're not doing any kind of discovery job here, but we can specifically manage BigIQ, endpoints. And then that'll be tied to a partition as well. And then you can manage the certificates that are associated with it. BigIP is really going to be tied into your IQ from like a management plane. One thing that is unique with BigIQ is that we do support on-device keygen. So if you have a requirement where the private key needs to actually get generated directly on F5, then you can support that flow directly from command as a way to trigger that type of enrollment as well. So let me go back into command, all right? And what I'm going to do is I'm going to go over to locations, and we'll go back to search stores, and we'll go ahead and filter this again. And what I have here is my BigIQ, right? And if I was to do an inventory here, we'd see the same type of output as we saw earlier. Again, you're going to have the same type of information. What's the client machine? What's the store path? This is a unique setting where it basically says if you're going to renew the certificate, do you want BigIP to do you want the deployed certificate that's linked to the big IP to do the renewal? So are you basically going to be doing like the evaluation and deployment of that certificate from big IQ down to the big IP? I marked it as false. And the reason I did that is because I have the same instance of big IP managed by an orchestrator, and I have big IQ managed by an orchestrator. So I'm going to go ahead and update it in both places at the same time. I don't need to do that, right? I can have actually big IQ do the work for me. So it would go ahead and get scheduled in big IQ, and then it get deployed from big IQ to IP. So you can kind of determine what that looks like, and that might become an option if you're not, let's say, doing stores specifically for big IP. We can ignore SSL. We can determine our authentication settings. This is exactly the same we saw for big IP, so no difference here. Okay. Now for this example here, I'm going to go to certificate search. The certificate we're going to be managing in this scenario is this one here. Okay. And it's for big IQ. And you can see there, it is actually tied to big IQ and for big IP. Okay. So because I'm managing both and I'm going to be, let's say, renewing this certificate, I really don't need big IQ to push it down to big IP as well, right? So that's why you have that little toggle option there. So if we look at this certificate here, we'll see the same type of information. So the serial number here is 54D8. If we go back over to my big IP and we go over here and we take a look at that certificate, okay, so here we'll just search for Mark again. This time is demo 2, and then that's that certificate there. And if we want to see that when in big IQ, we can. I actually have it set up where I'm going to go directly to that certificate, so we can just kind of get right in there to save on time. And we'll be able to see that certificate that's referenced, right? So if I wanted to renew this certificate, because I'm managing both of these integrations with a cert store, then that certificate would get updated, and then that associated alias would get updated as well. And as I mentioned earlier, I could have it set up where maybe I'm just connecting to big IQ. I go ahead and renew the cert, and because this certificate is tied to a virtual server from my big IP, I could also push that down as well. And you can definitely get into our GitHub repo that kind of gets into more detail on that and also obtain that extension as well. All right. So the last thing I want to go ahead and show you is the last integration, which is going to be for F5 distributed cloud. Again, same type of architecture slide. It will have its own extension that's available. Here we do have the concept of managing TLS certificates and also, CA certificates as well, specifically root certificates. So we can discover them, we can inventory them, and we have that full lifecycle management. So same type of functionality we saw earlier. Orchestrators would be deployed the same way, just loaded in with this extension. And again, they're listening to Keyfactor Command for any kind of work that is going to be processed. All right, so here's what I'm going to do. I'm going to go ahead and exit out of here. We'll go back into Command, and I'm going to go back to my certificate stores, okay? And I'm going to go ahead and find my 2 integrations for my distributed cloud, and then we're just going to go ahead and do a query on this one here. And we can see that I have 1 certificate under inventory. And we're going to actually see this actually being bound directly to a website, which I could have done with my other F5 instances, specifically for big IP. And we'll actually see that this certificate will actually get rotated directly on that website, which is actually being SSL offloaded from a site that it actually is providing access to, right? So we'll actually see that in play, which is pretty compelling, right? So here we have that certificate. We'll show you what that looks like in the F5 distributed cloud environment in 1 second. And then I also have my root certificate down here as well. And we'll see that directly within that environment as well too. For the actual configuration itself, it is a lot leaner. And because it's really a cloud-based solution, there's less parts to be able to manage here in my perspective. Where really all we're doing is we're putting a connection to directly the URL, the store path or the namespace that we're going to be doing the management for, which orchestrator is doing the work. And then we're actually not using credentials here per se for the actual connection. We're actually using an API key, right? So you actually would have the username set to no value, and then the password actually would be the API key itself. One thing I'll mention about the API key is that normally it has a 90-day expiration. So you have to kind of think about how am I going to rotate that key. You can definitely use an API in F5 to rotate it, right? So that's an option. Or if you do have, let's say, the requirement to rotate that key in F5, you could also rotate it directly in Command, either doing it manually here or with an API, right? And you could have the API key tied to an individual or a service credential. I've done a service credential, so it's kind of more of a machine account where I kind of define what kind of requirements and permissions that API key would have, right? And that's all information you could check out in your F5 documentation. We also list some of that information to kind of get this up and running in the GitHub repo as well too. All right, so that being said, let's take a look at this website that this certificate's tied to, and then we'll get into our F5 appliance. So I'm going to go over to a new browser here, and we're going to go to this website here. Okay, so this is the domain that I'm actually SSL offloading to a specific website. And if we actually take a look at this certificate here, right, you can see here under details, that's the serial number, right? So D7E0, all right? And we should actually see that here, right? So if we go back to our certificate here and we select that certificate, we can see that we have that matching serial number definition. That's the certificate that we have under management. And yes, we could query that as well directly within Keyfactor Command. You can see it's queried based off the thumbprint and the certificate store path, and we can see that association with that certificate store type, okay? Now, here's the thing. This is actually configured in the F5 environment to do SSL offloading to a specific website. And the actual site that we're actually offloading to is this one here. Okay, and this one actually doesn't have a certificate tied to it. So this is actually a very kind of real world scenario where you can actually see a certificate in use that actually gets rotated, and it would be able to be used right away. So you have no kind of downtime for that actual service itself. All right. All right, so let me go ahead and open up another tab here. And what we're going to do is we're going to log into our F5 distributed cloud. All right, I already had a session going there already. And what I'm going to do is I'm going to go to Multi-Collab App Connect, and I'm on the test namespace here. And you can see this is the actual load balanced configuration I have up and running. So if you go to my load balancers here and we go to HTTP load balancers, this is the one I currently have under management. It's hosted, it's valid, and you can see the certificate expiration date. Here I can actually get into the management of the configuration. And what we can do is we can actually see that configuration for that certificate. We can actually drill down directly into that. And then this is the actual certificate itself. And that's the one that actually is being managed directly by Keyfactor, tied to your root of trust, right? Because it's being issued against your certificate authority, right? And then if we want to actually take a look at that certificate in more depth, we can actually go down here to where it says certificate management. We can see the actual certificate that is under management. And then with that other integration we have, we also can see that CA certificate, which is tied to that root certificate as well. All right. So with that being said, if I go back into Command, right, and let's say I want to go ahead and renew this cert, it's going to be exactly the same as what we saw earlier. I'm just going to click continue this time, and maybe I'll be a little bit faster this time. We'll actually get to the job so we can see that it's queued up, right? And if we go to Orchestrator Jobs, you can see that we have this immediate job to have that certificate get picked up by the orchestrator and then delivered directly to my F5 instance, okay? So once the orchestrator does that, then what should happen is if we go ahead and refresh this, we should see that that gets updated. Okay, it's already been processed. We can go ahead and do a job discovery here, and you can see that there's the immediate successful job of doing the renewal of that certificate or replacement on the F5 appliance in the cloud. And then we can also see we have inventory being processed right away where it was successful. So if we go back to our certificate search in general, we should see that this has now been updated, where this is now the renewed certificate that's tied to that location. And now the proof is in the pudding, we can actually validate that. So this now has a new serial number of E571. So if we come back to my website here, I'm going to do a hard refresh, right? So we'll go ahead and do that. Okay. And if we take a look at that certificate, we should see that that is an updated certificate associated with it, right? E571, right? So just the power of being able to not only discover it, but also have the ability to renew it and have the automation to deliver that directly into F5, regardless of the integration, right? All three that we saw. Now, the last thing I want to show you is how could I do this without any type of user interaction? Well, let's go back into command, okay? And what I'm going to do here is I'm going to show you a workflow, okay? A workflow is a way that you can provide some type of like automation within our platform that gets triggered by some type of functionality. So in my example here, I'm actually going to trigger it with an expiration alert, okay? And what's going to happen is actually going to trigger this workflow to kick off. And if you actually take a look at this workflow, you can see that it's going to do a couple things. It's going to get the current time. It's going to grab all the locations where that certificate currently resides, right? So specifically, this is tied to my F5 distributed cloud integration. It's going to go ahead and do a renewal. It's going to send a notification out to an email to say this certificate got renewed just for visibility. And then it's going to run these cards here to grab some variables and then queue up the orchestrator to replace that certificate in the store. Now, there's a lot of different cards you can add in here to be able to do different operations. You could even do maybe an approval flow in here if you wanted to as well. But really what happens is this all can be driven off an alert. So if we come into alerts and we go to expiration, you can see that I have these different alerts scheduled where in this case here, if I have any certificates which are in this collection, then 1 week before they expire, it's going to kick off that workflow to do that type of operation, right? Where it's going to renew the cert and then have the orchestrator, push it and replace it automatically without any type of user interaction if needed, right? And if you see here, there's a certificate collection. That is actually the collection that we're actually referencing to see what certificates in there are going to expire within a week. But this could be whatever definition you want, 30 days, it could be 90 days, whatever it may be. So under certificates here, you can see there's a way to do any type of query, right? And then once you save that query, it can be saved as a collection. And in this example here at the bottom, this is my F5 distributed cloud certificate, or it could be certificates, right? If I have more than under management and any ones that are going to expire, then that automation could actually kick off. So let's go ahead and simulate a test. Well, this is not actually simulation. We're actually forcing this to happen as if we were doing this in the future. So I'm going to go ahead and do test, and I'll say, let's do next year, okay? And we'll do June, and we'll do it like a week beforehand. Give it a little bit of a buffer there, and we'll do when it actually would expire. So we'll do that. This should give us enough of a buffer to see that that certificate would actually expire within that 1 week time frame so that we can go ahead and automate this workflow to kick off. So we'll generate targets. It identifies that certificate as a candidate to go ahead and go through that process. And as soon as I click on start tests, then it's going to go to that workflow that it's associated with and going to run all those cards. And then we'll see all that type of operational functionality happen in an automated way, right? So we'll go ahead and schedule this and go ahead and kick it off. All right. And then we'll see, the interaction here. All right, so it's been successfully started. And for transparency, you can see that right here, this is the workflow that is actually being leveraged, right? And what we should see is a couple things, right? We should see that renewal happened automatically. Notice it actually got kicked off by a service account, right? So it's not me as an individual that actually is doing the renewal. And then we should see that job there where that certificate is, scheduled for immediate renewal or replacement on the actual F5, right? So when this go ahead and gets processed, it'll go ahead and disappear, which it just did. And then we'll see that history there. And we can see that the management job completed, and then it's returning back the inventory. So if we go back into our certificate search, we'll go ahead and see that it's now detected on that appliance. So if I go ahead and refresh that website, we'll see that certificate is updated. And then what we'll also see is I actually have an email sent out to this recipient to say, hey, this certificate just got renewed. Here's the details and what certificate store location it was tied to, right? So very powerful, right? For customers that are asking for full automation and for customers that are looking for post-quantum cryptography to be able to be crypto-agile, to be able to replace those assets in F5, we got you covered, right? Keyfactor Command, EJBCA Enterprise, pretty powerful stuff. That's all I have for today. I want to thank you very much for your time. And if you have any questions, don't hesitate to reach out and even set up a demonstration if you want to do a deeper dive. Thank you.
All right. I know we've got about 10 seconds left, so I want to say thank you to Byron and to Mark. Great information. Thank you all for joining us today. And please reach out if it really strikes something for you. We'd love to give you a demo. Thanks all.